Okay, welcome to SL paper 2 questions. So let's start off with question 3, which was the trigonometry question. So with a circle with a sector cut out of it like so, and they asked you to find the area of this shaded part. So the sector, and it was a triangle. So if you got the area of the sector, which was initially drawn here, take away the area of the triangle, you should have it. So from your formula booklet, the area of the sector, that was 4 and 4, and that's theta. So it would be 4 squared times theta, that's the area of a sector. And then take away the area of the triangle. Now this, you can just use trigonometry, a half AB sine C. So a half 4 times 4 sine theta. We don't know what theta is, we can tidy that up. 4 squared is 16, half of that is 8, so we have 8 theta. 4 times 4 is 16 as well, half of that is 8, and we have 8 sine theta. Beautiful. Alright, so that's part A done. You could tidy it up a little bit, but it's unnecessary. Part B then says that is equal to 12. Solve it. Well, you can sketch this on your calculator, sketch the line x equal to 12, see what they meet, and that would be your answer. So check that out. Maybe pause the video, give that a go on your calculator. If you can't do it, let me know. Theta, you should get 2.27. Remember to have your calculator in radians. Moving on, question 5. Probability, our strong suit. So you're given a probability of something happening. A is 0.62. The probability of a intersection B happening is 0.18. Okay, so you can draw a Venn diagram if you wish. You can see that that's 0.18 in the middle bit, and well, this won't be 0.62. This is A. You have to take away the probability of this bit already used, so that's 0.44. So that's a little sketch to start off with. Part A then is looking for the probability of A. So that's 0.62 in intersection with everything but B, so you can't include this B, so that 0.18 is gone, so you're only left with the 0.44 outside here. That's not in A, so you couldn't include it, so it's this 0.44 just, so that's the probability of A intersection with B complement at 0.44, just this. Part B then is some conditional stuff. Find the probability of A given B dash. Okay, so and they give you an extra piece of information. A union B dash is 0.1 complement. For the complement of A union B, so that's everything outside here. So that's 0.19. That's our leftover bits in the universal set, if you wish. Alright, that's as much information as we need to solve this because we have our probability conditional formula from our formula booklet. So that is the probability, so get it from your formula booklet, A intersection B complement all over the probability of B complement. Awesome. So probability of A, you have this from the first part, 0.44. Nice. Divide that then by B complement. So you could work out this, it's probably not necessary because you know that B complement would be everything outside of the B circle, is A and B. Everything outside, so that's 0.44 and the 0.19, there's nothing else. Add those together, you get 0.63, and then just type it into your calculator. 3 significant figures, 0.698. Wonderful. Okay, moving on. Question. The triangle, more trigonometry. Trigonometry and probability, definitely a weak area. You guys need to be working on those as much as you possibly can. Question 6. So there's some triangle that A and B, A is 8.1 and length B is 12.3 and the area is 15 centimeters. So the area is 15 centimeters squared, and we don't know this angle. You can call it whatever. I'm going to call it C. I got C. Okay. Find the largest possible perimeter of this, given that. Well, let's find that angle. Consider we have the area formula. We have sides either side of each other. So area would be 15. It's a half AB sine C, a half 8.1, 12.3 sine C. Now you can work this out in radians or degrees. I actually did it in degrees. So divide that then and do sine inverse, and you get C to be 17.52 degrees. Now, you want the largest possible perimeter. And because you don't have this side here, this could either be a narrow side or a long side, because C could be, like the complement of C, it could be the large angle. It's one of those triangles where we're not sure, is it the large angle or the small angle, because we don't know this side opposite it because of causes rules. So we presume that it's going to be its friend, 162 degrees 48, 180 minus that. So let's go with the obtuse option, which would probably give a bigger area, almost certainly. So we use the cosine rule because cause is ambiguous. So cosine rule to find this other side, let's call it x. X squared, we know this is either 17.52 or 162.48. We don't have enough information, but we'll go with the bigger one because it will give the bigger area and bigger perimeter. Squared minus 2, sorry, it won't give a bigger area, just give a bigger perimeter. 12.3 cos 6, 8. Okay. Type it all into a calculator, you'll find the answer for x when you square root it is 20.172. Add that onto this side with this side, and you get around 40.6. The perimeter will be 40.6. So you should be able to finish that one from there. Now, the last short question was very tricky. It is using both arithmetic functions, or arithmetic sequences and functions. So let's have a little look. So they have this very interesting function, e to the power of 2 sine pi x over 2 for all x greater than 0. Okay, so if it's a calculator question, you know we can type that into your calculator, so you might as well have done that. So I think it, can't remember exactly, but it does some repeating, some repeating multi-maximum, multi-minimum function like that. Now the k maximum point has the coordinate x equal to k, so it starts at x greater than 0, so it starts here, so x has to be greater than 0, so you're starting here. The first maximum on our calculator we can find using that function that x is 1 there. You can find the second maximum as x is 5. If you want, you can find the third maximum as x is 9. Now given that the k, now this just looks horrible, but if you understand it, the maths is super easy. So the first maximum plus some number is equal to the second maximum. So the first maximum is 1 plus a number, a, is equal to the second maximum, 5. Now a has to be 4. They're basically asking for the difference in the arithmetic sequence. Part B then, once again, so that's part A, is using some interesting terminology that maybe you're not familiar with 100%. Okay, so the sum of values is 861 of these values. You can see them 1, 5, 9, the sum starting at the first one. And they want to find what point that's on the end, when does it finish? What is that term? How many of them you need to do to get a total of 861 if you kept adding them? So 1 plus 5 is 6, plus 9 is 15, and so on, until you get to 861. Which one are you at for that? So if you want to find that term, you can go to your arithmetic formulas, and you can find any term. So UN formula, and you know the n, Sn, so you look for the sum, not an individual term, you look for the sum, Sn formula. So the sum, 861, is equal to n over 2, we don't know what that number is, 2 times the first term, which was 1 of our sequence, plus n minus 1 times the difference, which is 4. Okay? And we can start to solve that. If you want, you can rearrange it and multiply out, tidy it up, and you get 4n squared minus 2n minus 1722 equals 0. You probably could divide that by 2, then put it into your calculator, draw it on your calculator, and find where it crosses the x-axis. And it does, it crosses the x-axis at 2 places, when x is minus 21 and 21, so it has to be the positive one, because it's increasing. So it has to be the 21st term. So n is 21. N is 21. Okay? So there are the short questions from paper 1 HL. I'll be doing the long questions next.